Everyone, Miss Belcher here. I want to start off by telling you guys how much I appreciate all of your hard work that you put into my class yesterday. We got 164 assignments completed by the end of the day, so that's a really good job. Peer helpers, you were phenomenal. Thank you for motivating and encouraging those who were struggling. And if you were a person who was struggling, thank you for working hard and getting so many things accomplished. I had several students turn in 3 assignments. I had several students turn in 5 assignments, 6 assignments, and even 7 assignments. So thank you, peer helpers. I appreciate you. And thank you for those of you who worked hard. Now, as we move to this next unit, our first topic that we'll be talking about is plate tectonics. Now, you guys have probably talked about plate tectonics before, but we'll probably be diving a lot deeper than what you have in the past. So what I would like for you to do is go ahead and turn your books to section 1.1, pages 9 through 13. And I want you to go ahead and read pages 9, 10, and 11 for me. You may resume the video when you're finished reading 9, 10, and 11. All right, great, you're back. Now, on page 10, there is a picture here. It looks like this. I would like for you to draw that picture. Now, you do not have to include the paragraphs, but you do need to label the crust, mantle, outer core, inner core, lithosphere, and asthenosphere. Go ahead and do that now. All right, hopefully this top portion is completed. If you're like me, I'm such a wonderful artist. I drew something very simple like this, but everything is labeled. And then if we come down to our next portion of our notes, I will tell you that there's quite a bit that I'm writing in each of these sections, but I'm hoping that the more you write, the more you're going to remember. So for this inner core, I want you to go ahead and write a ball of hot solid metals. And it's got enormous pressure. This is what makes it a solid. So because of all of the pressure, it's going to make it a solid because it's pressing down, keeping it really nice and tight for a nice solid. Now the outer core is obviously on the outside of the inner core. Most of you can understand that concept. But for the outer core, important things to notice is that it's a layer of liquid metals that surround the inner core. So whereas our inner core is solid, our outer core is liquid. And the temperature and pressure are lower than the inner core, which allows it to be a liquid form. So how's the inner core different from the outer core? What we need to write there is that the inner is a solid, which has higher temps and pressure, whereas the outer core is a liquid because it has lower temps and lower pressure. Like that guy there. There we go. Okay, moving on to the mantle. The mantle is your largest part of Earth's crust. And with that being said, with Earth's layers. And with that being said, the mantle is Earth's largest layer. It's actually 2,900 kilometers deep. So that is super, super large. When we talk about the crust next, the crust is the thinnest layer. Mantle is definitely our thickest layer. Now the mantle is hot rock, which is less dense than the core. So less dense. So we get super, super dense to less dense. And right here, the lithosphere, that gets spelled today. Lithosphere is on the top, and it's cool and rigid. Versus the asthenosphere, which is more towards the bottom, and it is hot. It is hot and soft to make a thick plate. So with that being said, as you can see in the picture here, let me see where it's at here. Oh, here in this picture on this page. All right, we see that the asthenosphere is more towards the core, whereas the lithosphere is towards the top, closer to the crust. How does the density of the mantle crust change as it approaches the crust? What I would like for you to put there is that it is less dense as it becomes closer to the crust. So density is super, super strong, and then as we go closer and closer to the crust, it becomes less dense. I don't like that this is black. Let me change that. Okay, going down to the crust. Oops, I forgot to delete this. For the crust, it's a thin layer of cool rock, and it's the thinnest region, which is home to all life, including you and me. There's two types of crust. It's continental and oceanic. And how does oceanic crust differ from continental crust? The continental, you're thinking land, whereas the oceanic, that includes all ocean floors. What I would like for you to do now on page 13, when we are talking about the African plate, we are talking not only about the continental crust, excuse me on that, but also the oceanic crust. So we're not only talking about the continental side, which you think Africa, you're going to think the land, but you're talking both the continental and the oceanic crust. Excuse me on that while I had to reword here. So for the description, it's many large and small slabs of rock that make up a plate, and it fits together like a jigsaw puzzle. So if you were to think about a jigsaw puzzle about the size, about the shape of Earth, every single plate that we have on Earth would be like one jigsaw piece. And the African plate would be one of those pieces. And as we add another jigsaw piece to it, it would be like different pieces that make up our entire Earth. So clearly, every single place on Earth is included within a plate. Now, this question says, does the African plate cover part of the ocean around Africa and Africa, or is it only the continent of Africa? Just talked about that. It's not only the oceanic crust, but also the continental crust. So both the ocean and Africa. Which is thicker, oceanic or continental crust? Continental crust is thicker, but it's less dense, whereas the oceanic crust is thinner and more dense. Now, what I would like for you to do, if you have not done so already, go ahead and read pages 12 and 13 to see what I didn't cover in the video. All right, you're back. Now, this next section, it's going to talk about how the continents change over time. So, with that being said, this is a lot of evidence and a lot of scientific research and a lot of kind of vocabulary and support for this theory that they have identified. So go ahead and you can read section 1.2, 14 through 19. And then what I'm going to do is I'm just going to kind of give you your notes that help you understand the different pieces of continental drift and why they believe that Pangea is real and what evidence that they have. So go ahead and pause your video and read. Great, you're back. Okay, so moving on to this bottom section. If you read through everything, each of these pieces should sound familiar. So Alfred Wegener was that scientist who proposed the idea that continental drift actually occurred. Now, for evidence of continental drift, they have these ideas that we used to have South America and West Africa, they used to be joined, and that's because of fossils that were found. It appeared that the fossils that were found on South America were the same fossils that were on West Africa. So they believe that at one point in time, those continents were combined and the same life lived on both of those continents, which would obviously not work if they were separated, or if they were separated, correct. All right, now evidence from seafloor spreading. There are ridges that form along cracks in the crust, and molten rock rises through cracks and forms oceanic crust. The old crust is pulled away to make room, and it slowly spreads apart. I believe that you guys have talked about seafloor spreading in the past. Continental drift, it's just that hypothesis that says that Earth's continents move on Earth's surface. So every single day we are moving our Earth and our continents are separating or going closer together, depending on what continents you're talking about, but they are drifting apart from one another as we drift apart from South America, we would be getting closer to Antarctica, or the opposite there, we could say as well. Climates, there's climate change that has occurred. With that being said, like Greenland is, I always love the name Greenland because it's actually ice covered, completely ice covered, but its name is Greenland. But kind of ironic there. But with that being said, they believed they have found evidence of tropical plants actually occurring on Greenland. And how is that possible if it's that close to the poles? And South Africa, which is normally a warm climate, they have rocks that were actually scratched by sheets of ice. So with that being said, there's been climate changes that they have evidence from rocks and minerals and our Earth's surface that show and prove that climate change has occurred over time. And that leads us to our next one. Age of the seafloor. Main thing is that you need to know that youngest rock is the closest to the ridge, whereas the oldest rock is the farthest from the ridge. And oceanic floor is a lot younger than the continental. Moving on to Pangea. We've all heard the name Pangea, and all Pangea really, it's the idea that we were one big supercontinent approximately 200 million years ago. So just saying that all of our continents were actually smushed together. So how Pangea is different from continental drift. Pangea is the supercontinent, and continental drift just says that those continents over time have separated because of that theory of continental drift. Geology, this kind of is similar to the climate and the fossils in terms of they have evidence that rocks were actually found on two different continents that are very similar. Therefore, they believed that it was once one larger land mass. And ocean trenches. There are huge trenches in the sea floor, and oceanic crust is sinking into the asthenosphere. The old crust is destroyed at the same rate. So you can read about those as well. Now, if there are any of these terms that you are very uncomfortable with, please come and see me. And I know this seems like a lot that we wrote down today, but I can guarantee you that on your quiz and on your test, you're going to have to give me an example of how they have the idea that continental drift has actually occurred. And so any of this information that we covered today, talking about the climate change or the fossils that were found, or possibly even the rocks that were found, all of those would be evidence that would support the theory of continental drift. So I can guarantee that's going to be a question. So make sure that you remember at least one of those to help you out. Besides that, that is all that we have for today. If you are a person who still has missing work, please, please, please get something else done. I really want us to all be successful. Currently, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 kiddos on our team who are currently failing. And I would hate to have 14 kiddos fail before winter break. So please, 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 out of those 14 people, probably 10 of you are within a few percentages of raising it up to a D. So work hard these last couple of days, and I hope you all enjoyed this video. Come see me if you need help. Thanks. Bye.